There's a new frontier in aviation, hypersonic flight. Aircraft traveling over 5 times the speed of sound. The US is leading the charge, moving from single-use rockets to reusable hypersonic vehicles. The game changer? Reusability. Instead of burning up or crashing, these jets take off, hit Mach 5 and land back on a runway, ready to go again. This slashes costs and opens the door to rapid development and real-world applications. The impact is huge. Military forces could respond to threats anywhere in hours, not days. Imagine ultra-fast reconnaissance or rapid deployment. On the commercial side, we're talking about flights from New York to London in under 90 minutes. This technology could shrink the world as we know it. Let's dive into the key players and the tech making hypersonic flight a reality. It's wild, and it's happening now. First up, Hermeus, a company turning hypersonic dreams into hardware. In a field where bold promises often outpace real progress, Hermeus is actually building the future piece by piece right now. The US Air Force has backed them with a $60 million contract to test their new aircraft, the Quarterhorse. This partnership signals serious confidence from the military in Hermeus's vision and technical approach. Designed to hit Mach 5, that's over 3,800 miles per hour. Fast enough to cross the entire United States in about an hour. Imagine breakfast in New York and lunch in Los Angeles, all before most people finish their morning meetings. Unlike past experimental craft, Quarterhorse aims for repeatable, reliable hypersonic flight. It's not just about breaking records once, it's about making hypersonic speed routine. Its projected range? 4,600 miles, enough to cross the Atlantic non-stop. That means New York to London in under 2 hours, opening up new possibilities for global travel and rapid response. The secret is in the engine, a turbine-based combined cycle, or TBCC. This innovative propulsion system is the heart of Quarterhorse's capabilities. Hermeus built this hybrid engine around the proven GEJ-85 turbojet, used for decades in military jets. It's a foundation with a long track record of reliability and performance. The J-85 gets the plane off the ground and up to around Mach 2 or 3, providing the thrust needed for the initial climb and acceleration. At high speeds, the engine transitions. Airflow bypasses the turbojet and feeds a ramjet, which thrives at hypersonic velocities. This seamless handoff is what makes sustained Mach 5 flight possible. This hybrid approach lets Quarterhorse take off from a runway, break the sound barrier, and push to Mach 5, all in one flight. No need for rocket boosters or special launch platforms. For landing, it switches back to the turbojet for a safe, controlled approach. This flexibility is key for practical, reusable hypersonic aircraft. By leveraging existing tech, Hermeus can focus on the real challenge, integrating high Mach propulsion. It's about smart engineering, not reinventing every part from scratch. Ground tests have proven the TBCC works, including the critical turbojet to ramjet transition. These tests are a crucial step toward real-world flight. That's why the Air Force is investing. This isn't just theory, it's working hardware. The results are tangible and the momentum is real. Quarterhorse represents a new philosophy: use proven tech, innovate where it counts, and move fast. It's a blend of tradition and cutting-edge thinking. This could unlock hypersonic flight for military and eventually commercial use. The implications for defense, business, and even tourism are enormous. Hermeus is setting the template for the next generation of aerospace. Their approach could inspire a wave of innovation across the industry. The successful TBCC tests are a milestone for the industry. They prove that hypersonic flight is moving from science fiction to reality. The focus is on rapid iteration, not reinventing the wheel. By building on what works, Hermeus accelerates progress and reduces risk. Quarterhorse is more than a test bed, it's a leap toward practical hypersonic flight. It's a bold step into a new era of speed. The project's success could reshape how we think about speed and distance. Journeys that once took hours could soon take minutes. It's a smart, pragmatic approach to a massive engineering challenge. Every breakthrough brings us closer to a world where hypersonic travel is routine. The world is watching what Hermeus does next. Their progress is setting the pace for the entire industry. This is just the beginning for reusable hypersonic aircraft. The journey from prototype to everyday reality is underway. Keep your eyes on Quarterhorse. The future of flight is arriving faster than you think. Next, let's look at Stratolaunch, a company taking a bold and innovative route to hypersonic flight, one that's reshaping how we think about high-speed testing. Their giant rock carrier aircraft, with a wingspan wider than a football field, acts as a flying launch pad. It's the largest airplane ever flown, and its sheer size is a marvel of modern engineering. Rock carries the Talon A, a reusable autonomous hypersonic testbed, to high altitude before release. This unique pairing allows for flexible launch windows and rapid deployment. Once dropped, Talon A ignites its rocket engine and accelerates to hypersonic speeds, pushing the boundaries of what's possible in atmospheric flight. This air launch method avoids the thickest part of the atmosphere, making launches more efficient and reducing stress on the vehicle. It's a clever way to maximize performance and safety. Stratolaunch recently completed 2 successful powered flights of the Talon A2, both exceeding Mach 5. These flights mark a significant leap forward for reusable hypersonic vehicles. These weren't just quick tests, each was a full-duration sustained hypersonic flight, gathering valuable data over extended periods. Talon A is fully autonomous. It flies, collects data, and returns for an autonomous runway landing, all without a pilot on board. This reusability is a game-changer. No more ditching expensive vehicles in the ocean. Instead, the same vehicle can be flown again and again, driving down costs and increasing learning. After landing, Talon A can be inspected, refueled, and flown again within days. This rapid turnaround is key for accelerating research and development. At the heart of Talon A is the Hadley engine from Ursa Major, designed for repeated use and easy servicing. Its reliability is crucial for frequent hypersonic missions. The partnership between Stratolaunch and Ursa Major shows how specialized companies can accelerate innovation. By combining expertise, they're pushing the envelope of aerospace technology. The system, Rock, Talon A, and Hadley engine, works as a coordinated, reusable platform, setting a new standard for hypersonic testing infrastructure. These successful flights prove the tech is ready for routine hypersonic testing, opening the door to new research and commercial opportunities. Stratolaunch aims to be the hypersonic flight lab for government and commercial customers, providing a unique service that's in high demand. Their infrastructure is built for frequent, reliable, high-speed testing, with facilities designed to support multiple missions in rapid succession. The Talon A program is about rapid iteration and data collection, allowing engineers to refine designs and test new ideas quickly. Each flight advances our understanding of hypersonic flight, providing insights that will shape the next generation of aerospace vehicles. Stratolaunch is building the backbone for the future of high-speed research, creating a foundation for breakthroughs in science and technology. Their approach is about speed, reliability, and reusability, qualities that are essential for the next era of flight. The Talon A's success is a milestone for the industry, inspiring new confidence in reusable hypersonic technology. This is more than a test vehicle. It's a platform for the next era of flight, enabling experiments and missions that were once impossible. Stratolaunch is making hypersonic testing routine, turning what was once rare into a regular part of aerospace development. The future of flight is being built, one test at a time. With each mission, Stratolaunch brings us closer to a world where hypersonic travel and research are not just dreams, but everyday reality. Watch this space. None of this is possible without next-gen engines. Ursa Major is leading the way, supplying the Hadley rocket engine for Talon A. The Air Force recently ordered 16 upgraded Hadley H-13 engines, a shift from prototypes to serial production. This enables rapid, frequent test flights, swap engines, refuel, and fly again. The H-13 upgrades focus on reusability, robustness, and quick turnaround. Ursa Major uses advanced manufacturing like 3D printing to speed up production and improve performance. Real-time health monitoring and easy inspection are built in. This is the Formula One pit crew model for hypersonic flight. The government, Stratolaunch, and Ursa Major each bring unique expertise, accelerating progress. The real breakthroughs are happening in engine tech, making hypersonic flight practical, not just possible. As more H-13 engines roll out, expect Stratolaunch's test tempo to skyrocket. The quiet engine revolution is fueling the hypersonic age. Engines are the heart of this new era. Why all this investment? The military edge? Hypersonic aircraft could transform operations, delivering cargo or personnel anywhere in the world in under 2 hours. This rocket cargo concept is a top priority for the Department of Defense. For intelligence and surveillance, hypersonic jets offer unpredictable, rapid, and survivable platforms, far less vulnerable than satellites. They can penetrate contested airspace, gather intel, and return before detection. Future strike platforms could deliver payloads in return, compressing response times and complicating enemy defenses. The mere existence of these capabilities changes strategic calculations and deters adversaries. Hermeus's Quarterhorse and Stratolaunch's Talon A are test beds for these game-changing missions. Every flight generates data that will shape future military systems. Stratolaunch is the proving ground for next-gen hardware. Military urgency is driving funding and rapid progress. Hypersonic speed is a new form of power projection. The race is on to secure the technological edge. Beyond the military, hypersonic technology could completely revolutionize the way we experience commercial air travel, opening up possibilities that once seemed like science fiction. Imagine flying from New York to London in just 90 minutes, transforming what is currently a 7-hour journey into a quick, almost routine hop across the Atlantic. Companies like Hermeus are racing to make this a reality, with their Halcyon jet representing the future of passenger travel at hypersonic speeds. At first, tickets will be expensive, likely reserved for business travelers and the wealthy, but as technology matures, reusability and efficiency could make hypersonic flights accessible and sustainable for many more people. Military-funded advances in materials, engines, and flight controls are paving the way for safe, reliable, and incredibly fast passenger flights, pushing the boundaries of what's possible in aviation. Of course, regulatory and environmental hurdles remain, but new aircraft designs are being engineered to minimize sonic booms and reduce emissions, making hypersonic travel more compatible with our planet's needs. The vision is bold. A global network of hypersonic routes where you could fly from Los Angeles to Tokyo in just 3 hours, or from Sydney to Singapore in only 2, shrinking the world and connecting continents like never before. This leap in speed could transform business, tourism, and global connections, making international meetings and vacations more spontaneous and accessible. We're still likely a decade away from commercial hypersonic flights, but the groundwork is being laid right now in labs and hangars around the world. The test flights happening today are the crucial first steps toward a new golden age of aviation, one defined by speed and innovation. Soon, hypersonic travel could become a normal part of everyday life, changing how we think about distance and time. The future of flight is being built in real time, with every breakthrough bringing us closer to this extraordinary reality. Get ready for a world that moves at Mach 5, where the impossible becomes possible, and the future of travel is faster than ever before. The push for reusable hypersonic aircraft is a technological revolution. From Hermeus's hybrid engines to Stratolaunch's air-launched platforms, the US is building a diverse hypersonic portfolio. This isn't just about speed, it's about redefining military, intelligence, and global travel. Reusability is the key to making it all viable. The US faces fierce competition from China and Russia, adding urgency to the race. Successful test flights and big contracts are turning science fiction into fact. The next few years will be critical as prototypes become operational. What excites you most about hypersonic flight? Let us know in the comments.